Hi, this is an example problem from Chapter 8. And this is in this example problem, I'm going to show you my method for calculating torque, which is a bit different than the book's method. Use whichever one you find most useful to yourself, but I prefer this method. So pause for a moment and read the question. As you can see in this question, we're going to use our hand here to exert a torque on the wrench. And that's going to perhaps cause the bolt to loosen, right? If we can supply enough torque. Now, what do we know so far? We know the force magnitude that we've used here, right? So we know the strength of the force is 340 newtons. We can go ahead and write that down right here. So this is 340 newtons, right? And we can see how it's directed as well. So I always draw a picture of my object and draw my force. It's already been drawn here. The next step is to go ahead and draw your radius. The radius always starts here at the center of rotation. So there's the center of rotation, or actually what we call here typically the axis of rotation. And that's an axis that's coming out of the page, right? It's up and down out of the page, and the wrench will rotate around that axis. Now the radius itself is going to always start at the axis of rotation, and it's going to be drawn straight out to where the force is. And we know that this radius in this case, it has a length here, L, is equal to 0.4 meters. Now what I do is I always extend the radius beyond. And if I think of this direction here, this is the radial direction for this force. And I can also draw a perpendicular direction. I can also draw this direction. This is perpendicular to the radius. Now, the only thing we care about here is the force component that is perpendicular to the radius. Anything parallel, pulling with or against the wrench, in this direction, this is not going to cause it to spin. So parallel components, parallel to the radius here, we can ignore those. So what we need to do is basically there's a three-step equation for finding torque. And here it is down here. So the torque tau, right, it has a direction. We got to choose plus or minus if it's counterclockwise or clockwise. Counterclockwise is positive. We need to write the radius value, and then we write the magnitude of the perpendicular component of the force. So let's go ahead and write that equation down here. So the torque is going to be equal to plus or minus the radius times the perpendicular component of the force to the radius. Let's go ahead and draw that real quick. So there is F parallel. We can ignore that completely, and 90 degrees to that. There is our F perpendicular. We want to calculate that, which means we need to know what is this angle. Well, it's the same as this, right? These are vertical angles. And so we can solve for this now. The perpendicular component of the force, right? Looking at that right triangle, I take the magnitude, 340 newtons. And for the angle 50 degrees, the perpendicular side, that is opposite, so I use sine of 50 degrees. And now we can go ahead and complete this calculation for the torque exerted by the wrench due to the arm on that bolt there. So we got to choose plus or minus. Which way is this torque going to make it rotate? It's going to make it rotate in this direction, right? Which is counterclockwise. Clockwise would be opposite, which means we're going to choose the positive sign. The radius, as we said, the distance, straight line from the axis of rotation here to the point of application of the force, that's 0.4 meters. And finally, the perpendicular component of the force there, we already figured it out. 340 newtons times sine of 50 degrees. And you put this into your calculator, we get a value for the torque that's equal to a positive 104 newtons times meters. Newton times meters being the SI unit of torque here. So that is the answer for part A. Part B is simply, is this enough torque to loosen the lug nut? Nope, because the lug nut requires a torque of 110 newtons per meter. Is there anything we can do to improve this? Yeah, sure. Let's take our arm and make it completely perpendicular to the wrench, right? So if we pull up in this direction instead, all of that force is going to be perpendicular. In that case, it would just be 340 newtons, right? So we would be able to get 340 times 0.4, which would be enough to cause that bolt to turn. So answer to part B currently is no, but we know how to fix that.